Okay, so what's the difference between sine and cosine functions? Okay, here's a graph for a reminder. In red here we have a sine function, and in green a cosine function. This is where the 0 is. Sine of 0 is 0, so it starts at 0. And after, when the argument changes by pi over 2 in radians, we get a maximum. We get the next 0 when the argument changes by pi. 3 pi over 2 we get a minimum or a trough, and then the next 0 we get it at 2 pi. A full period happens whenever we have a 2 pi change in the argument of the sine. The amplitude of the sine, if it is just sine x, is going to be a 1. The maximum value is 1. So the values are going to change from 0 to 1 to 0 to -1 and 0. All of these are the same for the cosine function. The only difference is the cosine function is a 1 at 0. When the argument is 0, I'm going to have a 1, and I'm going to have a 0 at pi over 2, and a -1 at pi. So the cosine function is the same as a sine function, except it is displaced along the x-axis, which is expressed this way. Sine of x plus pi over 2 is equal to cosine of x. That's a relationship between both of them. In other words, whenever we would like to express simple harmonic motion, we can use a sine function or a cosine function. The difference between them is going to be whatever we are going to add in the argument here. Pi over 2 plus whatever else. Let me try to address that a little bit more in depth. So I pulled in here a website. It is called purplemath.com. We have here a sine function drawn like the one I just showed you, like the red one I showed you. The maximum is a 1. When the argument is 0, we get a 0. When the argument is 2 pi, we get the next 0. This is the full period, twice pi. Now the properties of the functions, if I have a function g of t, which is 3 sine of t, it's going to look exactly the same as this, except my amplitude now, instead of being 1, it's going to become 3. That's, remember, the expression that we have for x is a, that's the 3 here, a sine of something. Or v is v max sine of something. So that's the amplitude. We have here in gray sine of t, but look here in blue, sine of t minus pi over 3. It's the same function, but it is displaced by pi over 3. So it's moved sideways by pi over 3. So if in general I have any angle phi, we call it the phase angle, it's going to be displaced by that phase angle. That's really what the phi is in our simple harmonic motion equations. Now, what determines that phi? Remember t here, we are saying the value for t equals 0. That's what determines the phi. What do we want to have at t equals 0? Do we have a -1, a -0.3, a -0.5? That's what determines for us the phi.